Welcome to DozoChem. This video covers ionic bonding and ionic nomenclature. We're going to focus on elements in group 1 and 2 being bonded to elements in groups 15, 16, and 17. If you look at the periodic table, imagine a staircase between B and AL, SI and GE, AS and SB, and TE and PO. And that will divide the metals in the lower left of the periodic table down here and the nonmetals in the upper right. So that imaginary staircase is going to divide the periodic table between metals and nonmetals. Remember, hydrogen, even though it's way over on the left on the periodic table, we're going to consider it a nonmetal when we're talking about bonding. So ionic bonding, as you recall, is when you stick a metal and a nonmetal together, there's going to be a large difference in electronegativity. So one or more electrons will be transferred from the metal to the nonmetal, and you'll end up with metal cations. They'll have a plus charge, and nonmetal anions, which have a minus charge. So your next question is, what charges do they end up with? And that is shown on this table. Metals in group 1 are going to end up with a +1 charge when they lose electrons. Metals in group 2 are going to end up being +2. Aluminum, +3 when it loses electrons. And then the nonmetals in group 15 are going to end up with -3, group 16 -2, and 17 -1. So you'll need to refer back to this chart on the next slide. So naming ionic compounds is called ionic nomenclature. And the way you're going to do it is very simple. You just write the name of the metal, and then you write the name of the nonmetal, but you end it with IDE. When you go to write the formulas, what you want to do is use subscripts because you want to make the total positive charge equal the total negative charge. But one very important thing, you don't want to show the actual charges in the final formula. So here's 3 simple examples. You actually don't need subscripts in these examples because the plus and the minuses are going to end up being equal. First one's the classic example. Na is in group 1, so it's going to be a +1 charge, and chlorine is in group 17, -1. So since the pluses and minuses are already equal, you just write NaCl without the charges, and you don't have to use subscripts. Next example, calcium group 2, so it's +2. Sulfur group 16, -2. So again, just write Ca and then S without the charges because your pluses and minuses are already equal. And last example, aluminum +3 and nitrogen group 15, -3, so we write AlN. However, there will be situations where the plus and the minuses are not equal. So in this case, potassium sulfide, we have potassium K+, because it's in group 1, and sulfide, group 16, 2-. So those aren't equal. So what you're going to want to do is have 2 potassium ions for every 1 sulfide. And the way you would write it is make the 2 a subscript after the K, but do not show any charges in your final answer. So we can go a little bit faster through the rest of these. Sr is column 2, group 2, so it's +2. Iodine, column 17, so it's -1, so you're going to need 2 iodides, so SRI2. Aluminum ion +3. Bromide, column 17, -1, so you're going to need 3 bromides for every aluminum, so you make a subscript of 3 there. Lithium +1 because it's in group 1, and nitrogen -3 because it's in group 15. So you're going to need 3 lithium ions for every 1 nitride ion. So we'll make a subscript of 3 after the Li. Now the next 2 are a little trickier. If you have Al with a +3 charge and O with a 2- charge in aluminum oxide, the only way to make them equal is to put a 2 in front, or have 2 aluminum ions and 3 oxide ions. So now you'll have a total of +6 and -6. So those will balance each other out. So then you just make the aluminums, since there's 2 of them, into subscripts, and 3 oxides. So you give the oxygen a 3 as a subscript, and do not show charges in the final answer. And this last one's very similar. If you have Mg2+ and column 15 phosphide -3, we're going to end up with 3 magnesium ions and 2 phosphide ions. So we make those subscripts. So you may want to pause the video and just take a look at these again. But that's how you come up with formulas for ionic compounds from the names. And that's it for this video. Good luck.